Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through operations with surds. Firstly, what is a surd? So a surd is something that has a radical sign. So it could be a square root, could be a cube root, something like that. Now, if we have something like the square root of 2, see, the thing is that 2 is not a perfect square. Square root of 2, which is about 1.4142, blah, 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 is an irrational number. That means the decimal expansion goes forever and there's no pattern. So it's easier to write root 2 than write a whole heap of decimal numbers. So similarly, something like the cube root of 11 is a surd. 11 is not a perfect cube. So the cube root of 11 is an irrational number. So again, it's easier to write it like this rather than write its decimal expansion. So we're looking at operations with these radicals, these surds. So we're going to look at multiplying, adding, and subtracting these. Division, it turns out, is really simple as well. Let's look first, though, at simplifying surds. So here we're going to use the rule that root A times root B equals root AB. So multiplying surds together and also division is really, really simple. If you have something like root 5 times root 2, it's actually just the same as root 10. You just multiply these two numbers together. Multiplying and dividing goes really well with surds. So we're going to use this rule to simplify this surd. So what do I mean by simplifying? Well, I can find a number that is equal to this, but has a lower number under the square root sign. It's kind of like simplifying fractions. We're not changing the value, we're just writing it with lower numbers. So how do I simplify a surd? Well, what you need to do is find the highest perfect number, in this case perfect square, that goes into 48. Because this is the square root of 48, that's why we want the highest perfect square that goes into 48. So that turns out to be 16. Make sure you know your perfect squares. So using this rule up here, I'm just going the other way. I can write this as the square root of 16 times the square root of 3. See, the thing is, the square root of 16 is just 4, because 4 times 4 equals 16. So root 48 and 4 root 3 are the exact same number. This is just considered to be simpler because it has lower numbers there. We'll do the same for root 75. We need to find the highest square number that goes into 75. Well, that actually is 25. So I can write root 75 as root 25 times root 3. Now, root 25 is just 5. So root 75 is the same as 5 root 3. Same numbers, this is simpler. So this process works exactly the same for cube roots as it does for square roots. So when I want to simplify cube root of 32, I find the highest perfect cube that goes into 32. So cube numbers are like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on. So the highest cube that goes into 32 is actually 8. So I'm going to write this as the cube root of 8 times the cube root of 4, because 8 times 4 is 32. Okay, cube root of 8 is just 2. So I can write this as 2 times the cube root of 4. 4 is not a perfect cube, which is why I can't simplify further. So I can do the same here. Highest cube number, highest perfect cube that goes into 250 is actually 125, which is 5 cubed. So I write it as cube root of 125 times cube root of 2. And cube root of 125, as I said, is 5. So it'll be 5 times the cube root of 2. So the cube root of 2 is a surd. It can't be simplified any further because 2 is not a perfect cube. All right, let's look at going the other way. If I have 2 root 7, how can I write it as something like this? Well, 2 squared is 4, so I can just write this as the square root of 4 times 7, which is the square root of 28. So root 28 and 2 root 7, they are exactly the same number. This one, however, is considered to be simplified. Now, what if I wanted to do 2 root 7 to the power of 4? Well, you know, raising to the power of 4, you're just multiplying something by itself 4 times. We also know from our index laws, if we have a product here to a power, we just raise the first thing to that power So 2 to the power of 4 is 16. And now we're going to raise root 7 to the power of 4. So root 7 to the power of 4 is the same as root 7, so 7 to the power of a half, to the power of 4. Again, using our index laws, we can multiply these powers. This is the same as 16 times 7 to the power of 2. It's the same as 16 times 49, which is 784. All right, let's now look at adding and subtracting surds. So you can only add or subtract like surds, but there is an exception to this rule I'll show you in a second. But it is kind of like in algebra where you have like terms. So in this expression here, these two are like surds because they have the same number underneath the surd. So this is root 5 minus 3 root 5. So note the difference between 3 times root 5 and cube root, which has the smaller 3 there that's written in the radical sign. So root 5 minus 3 root 5, it's kind of like x minus 3x minus 2x. In this case, it's minus 2 times root 5. Now, the root 3 and the root 6 cannot have anything done to them because they are not like surds. I just have to leave them as it is, just like when we're adding and subtracting like terms. Now, I said before there is one exception to it, and it's in questions like this. So root 240 and root 60 can actually be subtracted. You're probably thinking, what the hell am I talking about? How are they like surds? Well, it turns out if I simplify each of them, they will be like surds. So simplifying this one, I need to find the highest square number that goes into 240. That's actually 16. So this is root 16 times root 15. That's equal to root 240. On the other hand, if I simplify root 60, the highest square number that goes into 60 is 4. So I've just discovered that the square root of 240 is 4 root 15. The square root of 60 is 2 root 15. And I absolutely can subtract these. So 4 root 15 minus 2 root 15 is just 2 root 15. If you have 4 of something and you take away 2 of them, you have 2 more. It's like 4x minus 2x equals 2x. So how do you know then when you can add or subtract them? Well, you have to check whether or not the surds can be simplified. In this expression here, neither root 5 nor root 3 nor root 6 can be simplified because none of them is divisible by a perfect square other than 1. Just like some fractions you can't simplify, some surds you can't simplify. So when you're adding and subtracting, you will need to first check whether or not the surds can be simplified. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.